Dear colleagues, I am glad to participate in the dust conference. I would like to present a report, Solid Atmospheric Fallouts as a Substrate for Urban Soil Formation, case study in Moscow. Authors. My colleague Sergei Shoba and I, we are soil scientists. And the third co-author is Vasily Shishkov. He is an expert in electron microscoping. The process of airborne dust deposition connects soils with atmosphere and other components of the city environment. Solid atmospheric fallouts are usually mentioned by ecologists in the context of pollution assessment. However, such fallouts from the atmosphere actually include very diverse solid components that are deposited on the surface of soils. So we can consider a solid atmospheric aerosol as a substrate for soil formation. Our long-term study on the composition of solid atmospheric fallouts was conducted over a set of summer seasons in the city of Moscow. There were mainly the places of our soil research. Moscow is situated in the central part of Eastern European plain, folded by loose sediments. It's in the southern taiga natural zone with humid temperate climate and percolate soil moisture regime. The average annual wind speed is 2.3 meters per second. The street dust has been studied. Airborne dust deposits studied within recreational and roadside zone. Were sampled into plastic containers, but by precipitation, by direct precipitation, dust samples in places of accumulation on urban road and construction structures were also collected. Morphological and chemical properties of dust and soil was examined with microscopes, a binocular microscope and polarizing microscope, and a scanning electron microscope with the energy dispersive spectrometer. We used soil analysis methods for dust because both dust and soil have a silicate matrix. It was revealed that dust deposition intensity significantly varied between different study areas. Mean dust deposition rates at our study sites varied from 10 to 50 grams per meter square per year. Such broadly corresponded to the overall mean in Moscow, 33 grams per meter square per year. Dust deposition rate in Moscow region is 2.5 grams per square per meter square per year. The studied dust samples were generally similar in the composition with abundant quantities of macroscopic particles of building materials, especially in samples taken near buildings. Dust aggregates with salt cementation, microplastic, textile and plastic fibers, fungal geyser and fragments of feces were common in samples from different study areas. The dust amount deposited on soil surface is not large. However, dust adds not only silicate minerals, but some specific components, metals, black carbon, and others. The spectre only shows elements with relatively high total concentration, more than 1%. Some dust units consist of salts, a large amount of carbon, sulfur, and chlorine give us evidence of chlorides, sulfates, and carbonates presence. Fragments of mortar and plastic fibers are usual in atmospheric dust. We found feces in the dust of both recreational areas which we study and at the roadside sites. Dust deposits within recreational zones were enriched in organic residues, pollen grains, and aeroplankton organisms. Roadside dust deposits also included asphalt concrete particles and thin films of hydrocarbons. We consider dust as an important substrate for urban soil formation. In our soil studies, we identify a special diagnostic horizon for urban soils. Its name is urbic horizons. Its chemical composition is very similar to street dust. According to our previous study, diagnostic horizons of urban soils developed as a result of pedogenic transformation of different substrates simultaneously with the surface deposition of these materials, including airborne solids. You can see fresh infiltration of street dust in the pores inside the upper horizon of the urban soil, red arrows. Dust is very important for urban soils as it enriches them with alkaline components, carbon and pollutants. Dust, together with additions of other substrates, provides a gradual upward growth of surface soil horizons. We suppose that not only construction waste, but small inclusions from the atmospheric fallouts provide the common geochemical properties of urban soils. Microscopic artifacts found in dust samples very similar to common microartifacts in urbic horizons. For example, microfragments of limestone are found both in samples of street dust and in the soil in the neighborhood. This picture shows the red asphalt cover. During the Soviet Union time, the area around the university, Moscow State University, was covered with a special red asphalt with high amount of lead and chromium. Now we find fragments of this road cover both in the dust and in the soil around the university. Thus, solid atmospheric fallouts contribute low quantities but a high diversity of materials in the upper horizons of urban soils. The composition of airborne dust includes aeroplankton, pollutants, particles of building materials, and other alkaline substances. Deposition of airborne dust can result in such soil properties as high contents of hydrocarbons, heavy metals, and high content of organic matter, and also neutral and alkaline pH, and so on. Apparently, solid precipitation provides the direction of soil evolution towards the geochemical homogeneity of all modern urban soils within the city. Atmospheric dust is a very important part of urban soils. Thank you very much for your attention.